My name is Matt Coley, and I've been a Java developer since around 2013. I got started with Minecraft modding back in middle school, and I've stuck with it ever since. I'm mostly known for my project Recaf. It is a reverse engineering toolkit for Java applications, and that's basically all I do now. It's everything I do is for Recaf.
You have Recaf, this tool, you have libraries. Are the libraries something you developed to be integrated in Recaf? Is this something like a cooperation between projects?
Most of the libraries that I do make are going to be at some point integrated in a recaf. The biggest one that I think has been a bit more public recently has been the BentoFX project. It's a docking framework for JavaFX. And there's been a number of docking framework libraries for JavaFX in the past. A lot of them are very lightweight layers on top of the tab pane control. So what they would do is they'd add a drag and drop event handler on the tab, and then you can move it around. And then when it receives a tab on another tab pane, it removes it from the old one, puts it on the new one. The only downside is if you want to add more heavy docking framework-esque capabilities, I found that leveraging an existing tab pane control does limit you. So I was using TreeMapFX at the moment, or at that point in time in Recaf for, I think, the last two major versions. And it got to the point where I wanted to add new things, and tab pane, ironically enough, was holding me back. So I went and remade the whole thing, and that became Bento.
So you mentioned Recaf. In a previous edition of this JavaFX In Action interviews, I talked to Chris Newland. He's well known for the JITWatch tool. So that's more a tool, I think, to really look into how the JVM is working. Recaf is to look into the Java code itself, correct?
Yes. JITWatch is pretty cool. There's a series on the Java subreddit actually right now with Casey Muratori about optimizing for the 1 billion row challenge. And somebody mentioned, oh, you should inspect the JIT. Actually, Casey mentioned it in the comments. It's like, oh, there's this cool thing, JITWatch. And yeah, it's in FX. It's a pretty cool application. But yes, for Recaf is not going to look at the JIT or anything that low level. It does look at the class file, which is lower level than a Java source code, but it aims to make things as simple as possible, sometimes to my pain and suffering, but I try and make it easy for people to make these changes and offer just generally a almost IntelliJ-like experience targeting a lower level of Java. So really the best way I can put it is I'm trying to remake the Java editor IntelliJ, but not targeting source code, targeting its compiled bytecode form.
Can you give us a demo of what this tool can
Yes.
do?
This is what Recaf looks like currently if you were to open it. So it tells you this is your build. So if you click on this, it will open the actual commit that it's based off of. So you can kind of see like August 31st, this is a while ago, you're 44 days out of date. You should update. It gives you some nice, useful links to start out with. I have the Recaf homepage, the user and developer documentation. The user docs over here, we have steps for installation. I have some requirements stuff. I explain how to use the launcher, why there's a launcher on this following page. And then I have I have like a category on just different kinds of obfuscation, because that's something I'll get into a bit later, but it's very much a work in progress. Most of my time I've spent on the dev docs further down on the page. The whole idea is that you will be able to script everything. So if you want to automate things in Recaf, I have a whole scripting interface here. And I don't have a UI for it yet, but there's also plugins. And everything is easily interacted with through the API, because if you're an enterprise developer, it's all CDI. So if you've ever used Boot or Jakarta web stuff, you're probably going to be familiar with everything. It's application scoped and all that fun stuff. That's enough for the notes and the links here. Let's actually get started with something. You drag and drop files onto Recaf in order to open them, or you can go into the file menu and open them here. You can also download a file from a URL or attach to a running process. But for now, I'm going to open up the demos folder, and I will showcase something that a user actually asked me about just the other day. This user came to me, and he had a question about this reverse engineering challenge he encountered. And I remade a very small demo. That's what this dumping loader jar file is. So I open it in Recaf, and when you open a jar file, it'll do a bit of analysis on the application first. So one of the things it'll do is it'll analyze any of the starting points of the application, and it'll put it in a list here. So I can just click main, it decompiles it and says, here's your main method, and immediately selects it. So if you have a big application and you're trying to find out where the heck is the entry point, even if there's multiple, it'll list them all there. So the thing that this application did was it has some code that generates a Java class file. Then it loads that class file into memory and invokes a method on it. So if I open this in the terminal and I do java jar dumping loader, you'll see that it prints hello. So if we follow this code a bit, we define a run method, and that's what gets called for the down here. And all the run method does is it has system.out, println, and then it passes the string hello. So it's very simple in this minimal example, but the person who has asked me for help had a bit more complicated code. The ask was very simple. He wants to analyze the bytecode of the class that gets generated in this file, the one that actually says hello. The way that you use Recaf, it was a bit confusing to him because most people, when they use Recaf, just hit Control S and it saves. So you saw that when I hit Control S, it flashes green. Green is good. It means that if you saved something, it has successfully recompiled all the code and you're good to go. And if I make a change like getting rid of semicolon and I save, it'll flash red instead. So when it flashes red, your changes weren't saved, and it'll highlight the line, and you can hover over that and says, column 4, you're missing a semicolon. And there's also, just like IntelliJ, the errors list. So if you had multiple, you could click there. And there's a button to go up and down to select it if you want to quickly navigate between them. Now, this one's pretty simple. You just semicolon to fix it, boom, bada bing. And when you save a change, it's only in memory. Recaf does everything in memory. And then when you want to finish, you would do export application here and then choose the file path. Let's say that this is a bit more of a complicated example. Not all code that comes from a decompiler, because this isn't source code, this is decompiled, is going to be immediately compatible with the Java compiler. Sometimes the decompiler makes mistakes. Sometimes the code is obfuscated. Sometimes you have to go lower level. Recaf is a bytecode editor, and we haven't looked at any bytecode. You right-click the name of something, and that gives you a context menu based on what you right-clicked on. So for this method, I right-click on the name of the method, and I have the option to edit it. I can view information about it, a bunch of other things. If you right-click on other things like a class name, an import statement, it's all context sensitive. Kind of just, again, I'm mirroring IntelliJ's features here, but going on with the example. This is the Java bytecode. It's a bit simplified versus what you would see in some other tools. The library I'm using in Recaf is ObjectWeb's ASM. Java came out with a very cool class file API, but I'm using ASM because it's what I've been familiar with for the past 7 years-ish. So we opened a jar file. So on the left is a workspace, just like in IntelliJ. So you have your packages. The class that we have open right now is example. There's obviously all the object ASM code because this is going to do bytecode manipulation stuff. And then I have my own single class that I extracted from Recaf to do the class loading stuff there. But whenever you click on a class in here, it opens it in the initial space. So the first space that you have stuff shown to you in Recaf will always be kept. So whenever you open something like a class, it will always put it there first because it's always a safe bet. You can always assume that that space will be available because I made it that way. This is Bento, so if you don't want something to be in the default space, you can take the tab and just move it somewhere else. You can also pop it out to another window if you want.
So now we're getting the demo of both the tool and the library at the same time.
Whenever I try and demo something, I always go bouncing between subjects, and it becomes a crazy mess. Recaf is so complicated. I could talk about this for days on end and still miss things. It's a project I've been working on for 7 years now. I have to check. But it's It's pretty big. There's a lot of stuff in here.
What was your initial goal? Was it to fix something in a compiled application and be able to
Yes.
change it because you didn't have the source code anymore, something like that?
Yes and no. Originally, there were other bytecode editors, and I can pull up some examples like dirtyJOE. So dirtyJOE is an overall Java editor. So dirtyJOE looks like this. You have very low-level access to the class file. You have your bytecode in actual bytes. You can see the hex representation of the bytecode here, the offsets based on the number of bytes there, and then the disassembled view there. You could use something like this in the past, and it's definitely capable, and it has a lot of neat features for its time to circumvent some of the obfuscation that was present back then. But it is so low level that if you are not very familiar with the Java class file specification, you are not going to be able to make any kind of notable change. So Recaf is aimed to take software like that, which is a bit more, it expects more of the users in terms of their domain knowledge of low-level Java, and I'm trying to make it as easy as I can in Recaf. As we saw before, you can make changes to an application by recompiling the decompiled code here, and there's a lot of magic that goes into that. Going to continue with the example. This person wanted to inspect the contents of the class file that was being loaded. And the way that it works is, reiterating, we have some class that gets generated. It makes a byte array. We load the byte array into a class, and then we invoke the run method. So if you are not familiar with Java bytecode and the stuff on the right here looks like a load of nonsense, I get it. Not everyone has the time to read a giant specification about what all this means. But you can kind of feel your way through and make something work with the tools that Recaf offers. So, for example, if we want to look for this bytes variable, we can Control F bytes, and there it is. You can also look at the declared variables, and you can click on it here to see where it's used. Same with any of the other others. But now we actually want to inspect the contents of these bytes and do something with them. So you could do something like load tab complete bytes, invoke static tab complete Java /IO. You could do this tab complete stuff, and that would be one way around it. But again, we're trying to make this as easy as possible. So how would we make it so that somebody who's never dealt with bytecode make a low-level change here and not on the screen on the left? Well, that's actually right next to the variables tab here. Java to bytecode. I'm going to full screen this so I have a bit more space, but there's a comment that I have that shows by default whenever you open this panel. Write some Java code here to convert it automatically to bytecode. You can access the class's current fields and methods and the current methods, parameters, and variables. So with that in mind, in the demos folder, I have a snippet of code here. I'm going to copy that, and I'm just going to put some space here and paste. And let me make this a bit bigger so we can see. This is obviously not Java compliant source. Again, there's some magic going on here, but I have a simple line of code, files right, some path name, and then the bytes. And as you can see on the left, we have our source, and on the right, we have our code. And it's mirroring the format that you see above, so that if you wanted to make some kind of change and not have to do with bytecode, you would do something over here on the left, and then you just take this, Control C, hit enter a few times. Right there was good. Paste. I don't want that return statement though. And there's also a try catch that we added here. So there's this exception here. I need to specifically copy that further up. If you don't use try catch, you don't have to do this. But I added an exception, so I kind of have to. But now that that's done, I'll move this over here. And when I hit Control S over here, you'll see the code update over here. Boom. So there you go. The reason why I have a separate editor here versus what you can just do over here is, like I said, if this code is obfuscated, you can't do anything. You can't edit obfuscated code. So in the Java class file specification, you can actually name a class space. That is a totally valid class name, just a simple space character. You can do this. Not in source code, but if you have an existing class that is named just the space character, that's fine. So if you try and save this, obviously the compiler is going to say, what the hell? You don't have a where's your class name? And I have to say it's right there, it's space. But that's obviously not something you can compile. But since we have this little miniature thing here that we can write any Java source code in, with the addition of some import statements at the top, you can take something that you would normally be able to write in your own little, text editor of choice, paste it into here, and then get the code that you want to be able to add without actually knowing what it's doing. So this makes life very easy for people.
Did you have to implement this yourself? How you go from bytecode to Java code and vice versa? Or are you using tools within the JDK to do this for you?
For bytecode to Java source code, I'm using decompilers. So on the left here, this is all decompiled code. There's no source in this application. We have a jar and then some classes, and that's it. And if you click this I button, it'll tell you some information about the class. This was compiled with debug information, so it does tell you that you were compiled from example.java, and it was compiled with Java 22. But if we want to change the decompiler we use, there's this gear button. I'm currently using CFR, but there's some other options you can choose. So we have Procyon. It's going to look very similar. Then we have Vineflower. They're very similar again. And then Fallback, which is something I made. It's not a decompiler. It takes the Java class, makes a skeleton structure that looks like source Java, and then just disassembles the method in it and puts an exception here so that it's technically valid code. But this is only for use if none of the others work.
These decompilers are also open source projects that you
Yes, these are all open source, and most of them are permissive license. So MIT, Apache. The way that we take the bytecode here and turn it over is we have our own disassembler and assembler written by a friend of mine, Jumanji on GitHub. It's Jasm. You can make your changes here, and when you save, it updates the workspace over here on the left. And whenever the workspace updates, it says to the UI, any UI that shows this class, I have an update for you. So in this case, the example class has been updated because the main method has been updated. That means I need to redecompile the code and show you the new updates. So if I change this hello world to hello world 2 and I save, you can see it briefly flashed. The decompiler said, oh, I'm done. There's 2. But for the compiling stuff like here, this is all the Java C API offered straight out of the box in your standard JDK. Most of the complicated things about the Java class file is just, we'll handle that for you. Don't worry about it. Don't look at the man behind the curtain kind of deal.
I'm impressed with the interface, like you dragging and dropping these tabs. So the IDE looks amazing. But at the same time, you're showing that you have so deep knowledge of what is happening in the Java code, in the bytecode, and how they go from one to the other. I'm amazed at how many layers there are in Java always.
There is so many layers. And whenever I try and explain to my parents or my friends, like, hey, Matt, what are you up to? What are you working on? And I open this.
As a Java developer, you have this very good Java runtime, which does garbage collection for you, which handles the compilation from class files to native code. So actually, you don't need to know all this stuff. You don't need to be an expert in bytecode, in how the JVM works. But on the other hand, it's amazing that tools like yours and JITWatch and Visual VM and all these other tools are there if you have a very strange problem, that it can help you to detect this. Yeah, maybe it's a garbage collector problem, or maybe you have a thread which is blocked, which you can see in Visual VM. Or I can imagine that sometimes it's code being compiled not in the best way, and you can see it here. Did you use it to detect problems, for instance, with the runtime?
Recaf isn't really used as a detection tool per se, like you would for Visual VM. It's mostly I need to fix something in production and I don't have the time to find the old source code that we lost 12 years ago, get it buildable, and make a monkey path. I have a jar file, you drag and drop it, and like I showed you, Control S in either the recompile screen where you can recompile, decompile code, or you make a little bytecode editor in the assembler. Either one of those, or I've done that several times at work, and it's been great. And I've heard some other people do it for similar things, but of course, when you give somebody a screwdriver, sometimes they use it for things other than screwing in screws.
What it's meant for, yeah. Um, while you were showing this, you were also showing the BentoFX library.
Yes.
So drag and drop, build this kind of applications, which really looks like IntelliJ.
And you can do that, move it to the side, and then boom,
Okay.
single click to close. If you
Okay.
don't want the logger, single click to close, and now you have all this space. So if you have a really big thing you want to show, you have all the space in the world. And of course, you can just click to open them again. You need them. When you're done, hide them away.
Okay. The TreeMapFX is also a library you created. Is this
Yes,
also in this
and that
application?
is here. TreeMapFX is this very elongated bar thing that I'm showing. In the current jar that we have open, different class files are going to be bigger or smaller than others. A class that does a lot of things like reading an entire class file is going to be a bit complicated. But then you take something like an interface, usually those are smaller, or if you have something really small like an abstract class here that only has like one method defined in it, very small. This screen is designed to show you how far along in the application you've renamed things with. So for example, if I go to the opcodes interface here and I will rename this to opcodes 2, I'll hit done. And then you can scroll over here and you see now this is green-ish. It gets greener the more stuff you've renamed in it. We haven't renamed any of the fields in the methods, so it's not a pure green. But these other files also changed colors because they directly reference the thing that you've renamed. So if you were to zoom out and you had an application like this and it was obfuscated, you could incrementally rename things and visualize how long you have to go to fully get rid of all the obfuscated names. But there are other tools that offer renaming capabilities, but this is just what I've done in Recaf. I thought it would be nice to actually visualize the progress you've made so far. So, TreeMap.
So obfuscating is that the variables get analogical names, mainly?
Yes. This is one of the few things I have most of the way done on the documentation, but we have a series of articles on different kinds of obfuscation. In this example, I have on the left the obfuscated code for a heap sort algorithm, and then on the right you can see the source code. It's pretty simple to understand. Over here you have 2 for loops and then a variable swap there, and then a recursive call to some other method that's further down below. But on the left, you can see that we have this injected switch statement, another one, and then we have a for loop here, which does this, but it looks a bit funky. Usually, if things don't look immediately like clean Java source code, that's where you can kind of understand that, oh, this is obfuscated. This isn't really that strong, but it's just an example. The one that most people are familiar with is name obfuscation, like you mentioned with renaming variables and stuff. You have a lot of freedom to name things ridiculous crap. The JVM, which I've linked here, the specific subsection for what rules you have, the only thing you cannot use are period, semicolon, left bracket, and slash. Anything else is fair game,
Okay.
which is why I said you can use space. So I have some examples here. So we have a basic data model for a user. We have their name and their identifier, and then a method which prints out their data here, and a main method to actually use it. Simple to understand program. And we start scrolling down and we find some examples. A lot of people, especially in the Android space, use ProGuard. And what ProGuard does is it'll combine as many names as possible to use the same character. So in this case, everything in the class that you saw above can be named A, just the single letter A. So we have the class name A, the string field A, the integer A, the local variables A and A, the method A. The main method has to stay the same, but the reason why this is valid in Java bytecode is because the type of the fields are different. So they are uniquely identifiable by their type, not their name.
Okay.
And then local variables, fun fact, they're just integers in the bytecode. We get around that in Recaf and we make them display as display names because in normal Java programs, you would probably want to use the variable names so that you can understand what variables are being used for what rather than just numbers. But you can abuse that fact because they're just numbers. You can name them garbage like this, and it doesn't matter. You can even have two strings named A. And because they're just referenced in the bytecode by integers, so like parameter 1, parameter 2, those can both be A even if they're both the same type, because that's not differentiable by type or name, it's by index. This is a tame example, believe it or not, naming everything A. You can also use reserved keywords like for, int, float, void. So we have void, float, int, short. And you could do the same trick before. You can name all the things void. So I just use different identifiers here and here, but you could name them all void. Another common one is to use the I and L with specific fonts, because if a tool uses a sans serif font, then you get I's and L's that look identical. So I'm using a font that makes it easy to see the difference between an I and an L, but that's not always the case, in which they would look identical even though they're unique. I mentioned before you can use the space character as a name, so yeah, try and compile that. And then
and try to reverse engineer this.
right. So the
And that's the
problem,
goal. That's the goal of this obfuscation, of course.
yes, this is the obfuscation that most people are familiar with because of ProGuard, but there's plenty of other stuff that I can get into. Jar files are crazy. There's a lot of shenanigans you can do with this. I have a nice little graphic here. It's linked if you want to find their other graphics. They have a page on GitHub which has a bunch of other stuff. Great artist. Zip files and jar files are the same thing. They just have different kinds of content of them. And I have examples of how you can do some shenanigans with jar files. So what do you think happens when you run this application or run this line of a command?
It's just a PNG that you just started. What is it?
Java jar hello.png.
PNG.
It is not just a picture, it is a runnable Java application. Let's see what happens when we drag and drop this PNG into Recaf. We see hello PNG, one class. Oh, would you look at that? Hello, the secret code is Rose.
No, I don't get it. So the pixels are probably containing this data?
Well, jar files have a cool attribute where you can have junk bytes in front of them. So we have the PNG at the front of the file, and then if you scroll all the way down, there's your jar. It starts here. So we have PK, which is the zip file identifier. Hello class is there. Hello class is there. And then you have the manifest down here. And you can say main class hello. Because we have a picture in front of the jar, it opens as a picture because Windows is like, oh, that's a PNG. And the extension is PNG. But Java doesn't care. It says there is a zip file at the end of the file. I'm going to use that. When you use java-jar, it assumes the file you give it is a jar file. And if it's not, that's on you. But the extension for Java jar doesn't actually matter.
I create these videos, so these interviews, because I want to learn about JavaFX. What actually turns out, I learn more about Java. The same happened with the JITWatch tool. It's so many levels that there are so many things that you can still discover inside the whole OpenJDK project.
I have another fun sample here, this deceptive one. Hello, deceptive. We have a decompiler. This is another tool. It's using the Procyon decompiler, and this is a front end called Lutton. There's so many different ways to pronounce these words. As you can see, it has no idea what to do with this file. It says that this method cannot be decompiled, and it does no operation, no operation, load integer variable 0, okay, -1, no operation, null, null operation, and then it ends. We look at that and we have to wonder what actually happens when we run it. Well, Java jar hello deceptive. Hey, would you look at that? It's the same message as before. And this is nothing to do with the obfuscation of the class itself. Everything has to deal with the jar file structure because it's a zip file and jars are zips. But if we open hello deceptive, then it gets a bit more confusing. This is hello.class as a folder, and it is 0 size, both packed and unpacked. And if you open that, it's empty. And then if we open another tool, JDGUI, and we put it in here, we open it, and worst off, it gives us code, the decompiler, and the decompiler, but it says hello world, which is wrong. Because if we looked at our application when we run it, it does not say hello world. So you can abuse jar files to make it look like the application will do one thing, like this, but do something else when you actually run it. The question now is, what happens when Recaf opens it?
You probably solved this, yes.
Recaf can actually recreate this capability, though. You have to dig into the settings, though. So it's in here. Zip parsing strategy. I made the JVM one, but you can use the naive strategy. And then if you were to open it this time, it says hello world. The way that that works is that if you use the zip file class from Java.io, it will read the first file. But if you read it with the one I made, which is the default in Recaf, it uses the one that you get when you've run with Java jar, which is probably what you want to do more often than not. But so while we're working on Recaf, I've encountered a lot of different problems where we've had weird edge case problems that most other tools wouldn't really pick up on. It may be a matter of they're expected to be used in more clean use cases where you're only looking at a regular jar, not created by a person with nefarious intent. But in Recaf, I have a lot of users who are looking at things like malware and other obfuscated code, which may not be malware, but maybe they suspect it to be malware. And it uses tricks like these. So I've had a lot of instances where every other tool is broken by some of these tricks. They either show the wrong information, they crash, fail to open, but in Recaf, rolls with the punches and everything just works. And of course, there's always going to be another problem that comes up down the road. But whenever that happens, a user will submit a ticket with hopefully a jar or a class that reproduces the problem, and then I'll fix it in hopefully a week if it's easy. But there have been instances where problems are very significant and complicated, and that takes more than a week to fix, which, again, Recaf is so complicated. There's so many things I can get into.
You can do so many things with Java, with the jar, and
Right.
you
Because
just try to fix them all or to be able to handle them all.
yes, because Recaf's goal is to be the one-stop solution for any reverse engineering for Java reverse engineering stuff. Just you have a jar, you have a class, you have a directory of classes, anything. The use case is hopefully going to be something that Recaf can help you with. And because I want to make it as easy to use and more prevalent so that it can be used by everyone for all the different use cases, I end up having to solve all these problems. So like I said, the sky is the limit.
The sky is the limit, and the wonderful thing is that you're using Java and JavaFX to make a tool to detect all these things in Java and JavaFX. So that's really great that you're using the tools itself to discover what's inside of them. Anything more you want to show?
This is a Java game that was made by Notch, the creator of Minecraft, a long time ago. You have these humans, and they break this tower, but this is just a video game. And it's a running Java application on my computer. And Recaf, attach, connect, and
This is a bit
open
similar
this.
to what Visual VM can do. So we can also connect to running systems, see threads, but you're looking at the code, I guess.
Right. I don't have all the features that Visual VM has. I have some things, like you can view all the properties, you can view some of the other metadata that the process publishes, system information. I need to clean up the threads views because this isn't really that useful. You just get a bunch of numbers, which not great. But the main thing that's interesting is this is an application that is running on my computer, and I can edit things on the fly.
Yeah, this sounds like the perfect tool for my 15-year-old son who is trying to hack all kinds of games and change its points.
I did a demo a long time ago where I changed the main menu text on Minecraft. So you can do it, and let me demonstrate the de-obfuscation feature. Pause. Before I open this, and I open this. I have in this analysis tab here a panel called de-obfuscation. This isn't super useful because we don't have any code here that's obfuscated, but you can select a bunch of these operations here, which will change how the bytecode of the class is working to simplify it. So you can remove code that's not used with code removal. If you have an if true statement, it will just get rid of it because that's redundant. If true will always go through. So things like that. And you would combine these in order. It even tells you what order it says, hey, if you're using this one, you should probably also put this one after it or before it. And when you do that, it says, thank you, and removes them. So if I put them in the optimal ordering, and then I move that there, you can see all the messages are gone. But the prime example of what I was going to show, I have this method which has a bunch of obfuscated strings and random garbage down here. And I have a bunch of things already configured in the most optimal order that I showed before. And what Recaf lets you do is rerun those operations over and over and over until there's no changes left to make. So if I play the video, you can see at the very bottom here, I have this transformer pass counter, and I went from 6 to 12. And now all the garbage that was in between is gone. And in that example, the strings there were still obfuscated. So I have a different video here where I showcase a very similar use case where I have all this text in a sample application which is obscured, and it's using this algorithm to decrypt it. So I'm going to drag and drop everything so they're all side by side. So in the top right, we have the decrypt logic here. It's just a XOR loop. You iterate over each character in the string, and then you XOR the integer value of that character, and then you do the next one, then the next one, then the next one. And when you're done, you take the character array of the values you shift around it, and you put it back into a string. So I have all these examples of these classes open, and I go to the de-obfuscation thing, and I'm going to pick a sample here. I go to the strings page. Here we have the preview, and then I open colon lining. And what that does is it will attempt to simulate method calls for values where it knows all the parameters. So the decrypt logic takes a string and a number. The string is obviously the original, but all shifted around. The number is how much you need to shift by. And then because the application logic for decrypting is really simple, it emulates it. And then anywhere where it gets a return value and it's like, oh, I'm done, it replaces the logic that calls the method with the value that the method call would yield. So you get the original text without any of the obfuscation stuff here, as you can see in the video.
Did your tool become some kind of de-hacker tool or just a hacker tool? Because what you're doing seems so much like magic and trying to reverse engineer what other people tried to make as difficult as possible.
I've had a history of messing with people who make obfuscation stuff. There used to be an obfuscator called Binskier. It's no longer active, but the developer had a Discord channel where he would post updates, and I was in a channel, and we'd banter at each other. So he'd say, "I have an update," and it breaks Recaf. So you would open a jar file, and the class wouldn't be recognized as a class. It would go down here in the files folder, because he would do something that makes it so that Recaf can't parse the structure of the class, which is a whole other thing I can get into, but this is about JavaFX, so I don't want to get too tangential. And I have other demos. I haven't even gotten to those. Like I posted a video recently about OpenGL and JavaFX. This is using the library Jogl, Jogl, the Java OpenGL library, and they offer bindings for Windows, Linux, Mac. All you need is the appropriate one for your operating system, and it'll work the same way. What I've done is I've made a custom canvas control, which displays stuff in an OpenGL application. It does freak out when you resize things, but whenever you're done resizing it, it fixes itself. So on the right-hand side, I have some shaders. I have a Mandelbrot set here, and this is a bit ugly, but I have a shader that follows your mouse. So if you're familiar with GLSL, that's all what this stuff on the right is. And because it's a proper component in the scene graph, you can apply scene graph effects on it. So you can make a wiggle, or hue shift, or blur. Glow doesn't really do a whole lot in this one, but wiggle is the most apparent. So I can go back to the Mandelbrot set and make it also hue shift and rotate. This one's less offensive on the eyes because it's a bit darker, but Jogl does give you a JavaFX canvas, but the problem is their canvas sucks. It's a basic region, so it implements the region class, but it doesn't actually draw anything there. It creates an external window and then snaps the external window on top of your program where the region is. So if you want to put anything on top of it, you just can't, because it's a separate window. And that was causing a lot of problems when we were looking at integrating JavaFX, or we were investigating JavaFX at work for a little brief stint. Whole dramatic tale to tell, but it was a blocker. So I ended up actually making this library specifically because I wanted to prove that JavaFX could be used at work. And I got it to work, so I made a little globe that you can move around, and it also can wiggle and look weird. But yeah, our application at work is more like this and less like this. But I just wanted to demonstrate that you can actually do this and make it a proper JavaFX app. So when I'm moving around, it's just a JavaFX event listener on the canvas. It's a mouse down listener, a mouse motion listener, and a mouse release listener. You could also do keyboard events. You can make the canvas focusable and then do like WASD or arrow keys to move. But I just didn't bother to do that. I just got a basic globe up and running.
But the rendering of this globe happens inside JavaFX, or?
It's in its own OpenGL context, and what's happening is I am taking the screen buffer of that context and I am painting it on my own canvas using JavaFX. The whole JavaFX isn't doing anything like actually drawing the globe. It is just taking the after image, in essence, of what is already in the OpenGL context and just showing it to you every frame. It uses Jogl here and then just JavaFX, and that's it. It's pretty basic, and the only AWT things I'm using are for determining how big to make your screen. But it uses a canvas, and then further down, the layout is pretty simple. I'm just snapping the canvas to the component dimensions. And then when we display the OpenGL stuff, I read the pixels from OpenGL, I put them in a buffer, and then I update the canvas pixel writer here, and I write the buffer back into this pixel buffer. And then further down, I draw that image on a canvas. So that's the basic implementation. But I've had this problem with JavaFX, which I have posted about 3 times now, and I've never found a proper fix, is what I call the white flash of death. Now, Recaf, as you saw before, is dark mode. So this bug, what happens is randomly your application just turns white and it does not go back. So the scene graph still works. You can click and move things and interact with it. It's just the rendering shows everything white, which nobody wants that. That you can't use an application like that. And I asked, and nobody was able to really give me a concrete answer on what the problem was. So I made my own library, JavaFX access agent. You attach the agent to your process, and it'll tell you when you're invoking a JavaFX method, not on the JavaFX thread. And I tried getting rid of as many of those as possible, and nothing fixed it. It was a mess. So what I did was I moved all of my usage of the built-in JavaFX canvas to the canvas I made in Bento, which I made to explicitly circumvent this. So I have this canvas wrapper around Bento that is actually drawing all these. And that prevents the white flash of death on Recaf. I have an entire directory dedicated to this canvas. It's a region. I have my own pixel, drawing API, and then I display it in an image view. It's a bit silly to display things that you want to draw as an image, but it fixes the white flash of death, and
And it
nobody has
works.
reported it in 7 months. I added this 7 months ago, so since nobody's reported the issue since I've made this change, I'm very hopeful that it's gone. But I don't know what's wrong with my usage of Canvas, or if it's something that's inherently wrong with Canvas. I have no idea.
Thank you for showing all your amazing work and publishing and sharing all your work and making these free libraries so that others can also benefit from them. I'm impressed with your knowledge of how deep you go into the GVM. It's amazing.
Recaf is the reason why I actually have my job that I have currently. A lot of people, when they come out of university and they only have the experience they've taken from courses, it's really hard to stand out if you are applying to jobs in the current economy. So if you have a giant project like Recaf that you've been working on for 5 years at the time, and you have a lot of domain knowledge that you've learned over the course of maintaining that, it really sets you out from the crowd. And it doesn't have to be necessarily a big project like Recaf, but there's a lot of people who I feel like if you make a passion project, you can really put yourself out in front of others. It's not guaranteed because a lot of companies will just, give your resume to an AI and that's it. But if you do find a company that does actually have human eyes and they look at your GitHub or some of the stuff that you tell them to look at, and they can actually take your value at face value that you present them with, you will immediately stand out amongst the droves of university students who are frankly just in the field for the money, which I get it, but I'm in it for the passion. Like I said, again, I'm pulling a Minecraft. It's always been about the passion for me.